and welcome to the Cisco support community. Today we present a live Ask the Expert event inside Cisco Live and Networkers Virtual. During our event today, our expert will be answering your questions on fax over IP. My name is Daniel Gerson, and I am the Content Manager for Cisco Live and Networkers Virtual here at Cisco. Our expert joining me today is David Haynes, a technical leader in the Customer Advanced Engineering team. Welcome, David.
Thank you, Daniel. Good to be here.
Now I'd like to briefly outline the format for today's Ask the Expert event. David will start with a short presentation on fax over IP for the first 25 minutes of the program, and then we will dive into the live question submission for the remainder of the event. During our live presentation, you may submit a question to be answered by David and a team of Cisco technical experts using the submit box on the left side of your console. Simply type your question and press submit. To see the latest questions and answers during today's presentation, be sure to click the refresh button just under the slides. You can scroll up to see the previous answers in the Q&A box. The team of technical experts is well versed in T38 configuration, so please begin posting your questions now to give us the best chance of answering them. We'll be asking polling questions during this webcast, and we encourage you to participate by answering them. In fact, just by participating in the polling questions, you'll be eligible to win a one-year Premier Pass to Cisco Live and Networkers Virtual, which will give you access to hundreds of PDFs and on-demand webcasts. So let's get started with today's event. We'll kick things off with a polling question today. On a scale of 1 to 5, with 1 being not important at all and 5 being very important or critical, please rate the importance of fax communications within your organization. Take a moment to answer, and we'll check out the results. Okay, let's have a look at these results. Okay, thanks for answering that polling question. Now I'm going to hand the mic over to David, who will begin his presentation on fax over IP.
Thank you, Daniel. Today I'm going to cover, as Daniel said, fax over IP. This presentation really focuses on the T38 protocol, which is the de facto standard for fax over IP. The first part of the agenda today is going to be an introduction to fax over IP and T38. This will be a level set to get us all on the same page as far as these technologies are concerned. The next section would be some quality of service design considerations. Most people are very familiar with quality of service for voice over IP, and we're going to go ahead and dive into how you do quality of service for fax over IP. The next section covers implementation models. Basically, what are the different ways you can implement T38 and fax over IP in your network. Then the next section is the best practices, and these are just little tidbits of information as far as integrating fax over IP and T38 into your network and the best ways to do this. And then we'll wrap everything up with a key takeaway section where I'll highlight the main points from this webcast. So let's get started with the first section, which is the introduction to fax over IP and T38. Most people aren't aware, but fax was invented 30 years before the telephone was invented by a Scottish clockmaker named Alexander Bain. It involved a swinging pendulum and an image on a plate, electrical plate, and another pendulum. The same machine was swinging on the other end of the connection with some electrically sensitive paper. As these pendulums were swinging back and forth, the image was sent over the wires. And this was the first instance of images being transmitted over a fax type apparatus. Today, obviously, fax is ubiquitous as a communication means throughout the world. There's two big standards, the Group 3 and the Super Group 3 standard. Group 3 is supported by every fax machine you'll run across today. And Super Group 3 is an extension of that standard, which provides higher speeds. And the reason Super Group 3 is differentiated is because it uses a whole different modulation method. And sometimes from a network design and best practices standpoint, you need to deal with these differences. There's different methods for doing so, which we'll see later in the presentation. If you look at fax over IP as a whole, you can go ahead and any kind of real-time fax over IP protocol can be broken down into one of two subcategories, either pass-through or relay. And I'm specifically going to just discuss the real-time fax over IP transport mechanisms here. I know some people are probably familiar with T37, which is a store and forward method of fax over IP, where the fax is converted to an image and sent over email or SMTP. And we're not going to cover that here because that breaks the real-time nature of fax and is pretty much not being used anywhere near it used to be. It's pretty much fading, and T38 is pretty much taken over as the fax transport protocol. But looking at fax over IP as a whole, you have these two subcategories, pass-through and relay. And this seems pretty basic, pretty simple. Pass-through basically uses a voice codec, G.711, to transport the fax information, whereas relay uses a process of demodulation and remodulation to transport the fax information. And we'll look at that in a little more detail. What gets confusing about fax over IP from here is pass-through and relay can then be broken down even further into very specific transport mechanisms. And this is one of the reasons why fax over IP is very confusing to a lot of people. As you can see, pass-through with Cisco products, there's two different ways to do it. One of them is pass-through using what we call an NSE negotiation, and NSE simply stands for Named Signaling Event. It's a Cisco proprietary way of negotiating, and this is only supported on Cisco products. We also have something called fax pass-through on Cisco products, and this uses the call control protocol, such as HC3 or SIP. If you then look at the relay side of things, we have Cisco Fax Relay, which is Cisco's proprietary pre-standard implementation that was developed before T38 was released. This is being phased out, but there's still a lot of it out there because it was the default in Cisco voice gateway products for quite a while. We then have T38, but like pass-through, it can have two different switchover mechanisms. One of them is the Named Signaling Event, or NSE method, which again is Cisco proprietary. And then we have standards-based T38. And that's what we're going to focus on today because that gives us the most advantages, especially in terms of operating with third-party devices and so forth. But I want to give everyone an overview of the fax over IP world, so to speak, and show you where T38 and specifically standards-based T38 fits in. So let's look at T38 a little bit more in depth. As I mentioned to you, we can use the NSE switchover method with Cisco products, which is proprietary, or the standards-based method, which uses a call control protocol such as HC3, SIP, or MGCP. As I mentioned earlier as well, T38 is now the de facto standard for handling fax transmissions. When I first started dealing with fax over IP as a member of Cisco's technical support team, we were seeing, as far as T38, just barely any support requests coming in at all. Maybe 5% of the total fax over IP requests dealt with T38, and this was about 10 years ago. And today, pretty much everything deals with T38. Very rarely will we see a case coming in on T37 or pass-through. So T38, just by looking at that one little sample of cases coming in Cisco technical support, you can see that T38 is pretty much taken over. There's two versions of T38 that are specific to Cisco. One is the 1998 version, which you'll often see referred to as version 0. And this has been supported by Cisco ever since its introduction years ago. Recently, we started supporting an extension of T38 version 3, which allows for Super G3 or SG3 to be transported over T38. And that's a pretty recent development from this year. One thing to bear in mind with T38, and this comes up from time to time, is that unlike most video and audio codecs, when you're sending those over IP, which uses RTP as an encapsulation, the real-time protocol, T38 does not use RTP. In its place, it uses what we refer to as a UDP TL header. And what this means is that if you want to send secure faxes using secure RTP or SRTP, it's not possible with T38. Also, features such as CRTP or compressed RTP also not available when you use T38, and that's just something to bear in mind from a design point of view. So let's look at how T38 works functionally, specifically on a voice gateway. What happens with T38, and this goes for other relay protocols as well, like Cisco Fax Relay, but T38, what happens is you have the voice gateway basically on the the originating side. It sends zeros and ones. That's where it talks in the zeros and ones. It digitizes an image in the fax machine. And to send those zeros and ones across the network, it has to modulate those zeros and ones. And what I mean by modulate, it has to make those zeros and ones audible, because fax machines were initially designed to work over voice networks, not computer networks. They were designed to plug into telephone networks. So what happens is these zeros and ones are modulated, and that's those beeping, the tones we hear from fax machines when they're sending. That's those zeros and ones being modulated. On the voice gateway side, we take those when it's configured for T38 Fax Relay, and we demodulate those. In other words, we strip that audio off that signal, and we just pull out the zeros and ones. We can then package those zeros and ones into T38 and ship those across the IP network. So we're just shipping the raw data from the fax messaging across the network. When we get to the gateway on the other side, it just does an inverse of the process the originating gateway performed. In other words, it's going to take those zeros and ones, that fax information that's inside those T38 packets, and it's going to remodulate those. And by remodulate, I simply mean it's going to make those zeros and ones audible again, put them on an analog carrier, and send those back out to the terminating fax machine. Now, from the fax machines on each end, from their perspective, they have no idea that this IP network is there, that this demodulation or remodulation even occurred. It's completely transparent to them. They think they're talking just over a regular voice network. So let's look at a configuration for standards-based T38. For SIP and H.323, it's pretty simple. You can configure it under the dial pair, and you can also configure it globally under voice service VoIP. In this slide here, you see the newer command line, because you see the version word, the version keyword there, and then you see you can select between 0 and 3. If you select version 0, you're basically supporting just group 3 faxes only with T38. If you select version 3, you're supporting both group 3 and SG3 faxes, which is the newer feature I mentioned earlier. If you have iOS before 15.11t, you won't have that version option, that version keyword available to you. Only the version 0 is supported, so obviously you don't need to define that in the command line. If you're looking for skinny protocol or STCP, for standards-based T38, this is not supported. So you would need to use a negotiation method where we use those named signaling events for T38, which is a Cisco proprietary method. So it's a little confusing that you can use T38 for skinny voice gateways and so forth, but it's not going to be a standards-based switchover method. So these skinny devices wouldn't operate with third-party devices, such as a fax server. For MGCP, you can configure standards-based T38 by configuring the FXR package. One thing to remember about MGCP is that it does not have that version 3 support. If you want to do supergroup 3 over T38, you have to use either H.323 or SIP. Hey, Daniel, back to you for a poll question.
Thanks, David. Let's check out our second polling question. Please mark the answer that best matches your organization's approach to the use of T38 for fax communications. Have already deployed T38, in the process of rolling out T38, considering the use of T38, minimal or no interest in T38. Please take a moment to answer. All right, let's have a look at these results. Great, looks like some folks are considering the use. All right, I'm going to pass it back to David.
Great, thanks, Daniel. Okay, we'll go to our next section, which is quality of service design considerations for T38. A question that I often get is how customers come to me and say, I have an existing voice over IP implementation, and I want to start running fax over IP. And the question is, are the QoS policies that I've configured for voice over IP, are those sufficient for fax? And the answer generally is yes, they are. As a rule of thumb, if you have a good voice quality between two locations, then you should be able to send faxes between those two locations as well. One minor caveat that we will discuss involves packet loss, where fax does not have as much of a tolerance for packet loss as voice will. And the way you deal with this from a quality of service perspective is you're able to piggyback your fax traffic on top of your QoS policies for voice. And we'll see in a few slides how exactly that is done. Let's discuss specifically T38 and packet loss. As I mentioned, for voice, we have lots of mechanisms for dealing with packet loss. Within the voice codecs, we have things such as gap fill, silence fill, concealment, interpolation, all kinds of different mechanisms that can make up for lost packets. Additionally, if you lose a 20 millisecond voice sample here and there, that's not going to be something that is detected by the human ear. So, packet loss, while you don't want to have a lot of it for voice, you can have a minimal amount and still have satisfactory voice quality. Well, fax, and specifically T38, it's data. Like I mentioned in the beginning, it's zeros and ones. You can't even lose a single bit of this without corrupting an entire fax frame. So that's why packet loss can have such a big effect on fax over IP and T38. Fortunately, with T38, and one reason why it has become the de facto standard, is that it has a very robust redundancy mechanism. And by enabling this redundancy mechanism, you can get around some of the packet loss issues. So if we were to look at, as far as the redundancy of T38, you can see an example here. We have basically 3 T38 packets. And what T38 does with fax information is that it basically carves it up into what it refers to as IFPs, or Internet Fax Packets. And it makes these into primaries and secondaries. Primaries are the first time that information is sent across the network, and then it can add redundancy by making a secondary of that primary. So in this situation, if we were to lose, in this case, that very middle T38 packet, we're still able to reassemble the full fax frame. Reason being is because IFP 1, 2, and 3 still make it through the network. As you can see, IFP 2 is piggybacked, a secondary copy of it is piggybacked on with IFP 3. So this kind of shows you just generally how a T38 redundancy will work. One thing to be aware of is that enabling T38 redundancy, it does increase your bandwidth. So you don't get something for nothing, as they say. We'll see exactly the bandwidth differences in an upcoming slide. So a quick summary from a quality of service design parameters comparing voice to fax. And I pulled on that first row, you see voice quality of service parameters and what is recommended as far as to ensure good voice quality. And I pulled these directly from the voice SRND on the Cisco website. And it's recommended for voice as far as delay less than 150 milliseconds. And then you can see down below for T38 fax, fax can tolerate delay up to 1,000 milliseconds. So obviously, if your QoS is set up to keep delay less than 150 milliseconds for voice, you'll be fine with T38 fax. If we then look at jitter, they recommend for voice to keep jitter at less than 30 milliseconds. And for fax, because of its high tolerance for delay, Cisco uses very deep jitter buffers, fixed jitter buffers, in fact, of 300 milliseconds. So as you can see here as well, jitter is, if you can meet it for voice as far as the less than 30 milliseconds, then your fax will be fine. The last column shows packet loss. Now for voice, it says the recommendation is less than 1%. Because of the mechanisms I mentioned earlier, voice can tolerate some packet loss. Well, with T38 fax, we just say no packet loss. Now, in reality, what happens is you can lose some packets here and there without having T38 redundancy, and the fax may go through. But we have also seen scenarios where a single packet at a certain point in the fax transaction can cause the call to really degrade or even fail. So it's just easier to say no packet loss for T38 fax unless you're using redundancy. So let's talk about the piggybacking on the voice over IP QoS. In this scenario here, we have a fax machine, obviously a voice gateway, and configured on this voice gateway is a dial peer. In this case, it's dial peer voice 100. So when we talk about piggybacking, what we're saying is that any call, so a voice call will match this dial peer voice 100, and all fax calls start off as voice call. So once that voice call matches this dial peer and gets set up, and the call switches to T38, whatever QoS parameters are set for that dial peer, the fax call is going to automatically inherit those because that dial peer is matched from the beginning. So whether that call stays in voice mode or it switches to T38, the same QoS parameters are used. So in this case here, you can use the command show dial peer voice 100, and you can see that for IP media, the DSCP is set for EF, and the signaling is set for CS3. So just by configuring fax over IP on a dial peer, or T38 specifically here, you end up getting all the quality of service attributes for that dial peer automatically applied to T38. And this is how we piggyback fax over IP quality of service onto existing voice over IP quality of service configurations. Next, I want to go ahead and go through a few implementation models. As you'll see, there's a few different ways that fax over IP can be implemented in your network. I kind of want to cover these and kind of talk about some of the advantages and disadvantages of each one. The first one is what we simply refer to as a gateway-to-gateway model. There's no Cisco Unified Communications Manager involved here. This is your most basic setup for fax over IP. In this scenario, the first thing that happens is a voice call is established. And actually, this is going to be the same step for all the implementation models. As I mentioned previously, all fax calls start off as voice calls. So in this case, we have a voice call being set up between two voice gateways using H.323 or SIP. And then we now have our voice media stream flowing between the gateways. The next thing that happens is we have to have some sort of a switchover. Now, if it's an NSE-based switchover, which I mentioned to you is Cisco proprietary, that occurs within that voice media stream. If we have a standards-based T38 switchover, that occurs in the call control protocol. So you can see the number 2 right above the gateway showing the switchover in the call control protocol. And you can also see it, the 2 down in the voice media where the switchover is occurring via NSEs. And then ultimately what you end up with is your T38 fax media flowing between the gateways. So this is just a very basic way that 2 gateways would bring up a fax call. If we go ahead and extend that model and bring in Cisco Unified Communications Manager, we'll see that there's 2 different ways to do it with Cisco Unified Communications Manager. This first way is called gateway controlled, and you'll see why here in just a second. In this scenario, we again start off just like the previous one. We have the voice call being set up. All fax calls start off as voice calls. So we have our voice media flowing between the 2 voice gateways, and this voice media stream was set up by Cisco Unified Communications Manager. We then have a switchover. In this case, the switchover is going to be through NSE packets. And these NSEs occur in the voice media stream, and if you notice, they don't involve call manager at all. That's why we refer to this as the gateway controlled method. The gateways are controlling the switchover, and once this call switches over to T38 using these NSEs, Cisco Unified Communications Manager has no idea that this switchover has even occurred. It still thinks the call is a voice call. It was kind of done behind the back of Cisco Unified Communications Manager, so to speak. The important thing to remember about this implementation model is that this is the only way to support skinny voice gateways. This is the only way skinny voice gateways can implement T38. The next method is referred to as CA controlled, which means call agent controlled T38 with Cisco Unified Communications Manager. Again, since all fax calls start off as voice calls, we have Cisco Unified Communications Manager setting up the voice media call between the 2 voice gateways. We then have our switchover. But this time, notice that the switchover is not occurring via NSE packets in the voice media stream. It's actually occurring through Call Manager using the call control protocol. And this is really important because Call Manager is now involved in the switchover to T38. And this is standards-based T38 switchover with Unified Communications Manager. This is a Cisco best practice, and this is what Cisco recommends you guys to do if you can. If you have Call Manager, if you have voice gateways, this is the way to implement T38. One thing to be aware of is Unified Communications Manager and its T38 support. Most people today are running version 6.01 and later. But be aware, just for those who may not be, if you're running an older version of Cisco Unified Communications Manager, there can be restrictions on its T38 support. For example, if you're running 501, then you could have you would only be able to support H.223 and SIP. You wouldn't have MGCP support for T38. Next, let's go ahead and look at some best practices for implementing T38 Fax over IP. First thing I want to cover is bandwidth. I alluded to this slide earlier. You can see here, this is one of my favorite slides just because it quickly highlights one of the main advantages of T38, which is bandwidth. At the top, you see some common voice codecs and the bandwidth they consume. You then see pass-through. And obviously, no surprise, a pass-through call takes up 83 kilobits per second, the same as a G711 voice call. Since pass-through does use a G711 codec. Pass-through does have the ability to do redundancy. It doesn't help a lot, but it does have that ability, but you can see how the bandwidth just skyrockets to 170K. You then look at T38. So T38 with no redundancy, you're looking at less bandwidth than a G729 call. For those that have WAN links where bandwidth may be somewhat restricted, and you're dealing with call admission control or CAC, these bandwidth values can be somewhat important in your network design. You then can see how with T38, as we add in redundancy, the bandwidth does go higher. But even T38 with full level 2 redundancy, you're still looking at 57K, which is much less than the pass-through call at 83 kilobits per second. So I mentioned earlier on the very first slide, I defined supergroup 3 and then just group 3 faxing. And we have run into issues now. Technically, a supergroup fax machine that supports SG3, it should downspeed to G3 with no problems. But in reality, we don't always see that happening. So we've had to come up with measures in order to deal with SG3 fax machines. We're trying to get those over IP and so forth. One method that some people have used is to use regular version 0 of T38 for their G3 calls, and then when the SG3 calls come up, then they can use something like a pass-through configured by the modem pass-through command in the Cisco Gateway CLI. Some people have done that to handle SG3 faxes at their native speeds. Another option, especially with a recent feature of SG3 support over T38, you can upgrade to the 15.1.1 tier higher, and you can now support SG3 natively over T38. So that's now a solution as well. But what most people are still doing, because most people are running the latest and greatest iOS, is that they're using what we have known as the SG3 to G3 spoofing feature. And this is enabled by default with T38, and I think it was started about 12.4.4T. And what this feature does is it basically convinces SG3 fax machines that the other side is G3, even if it isn't. And by doing this, it forces these fax machines to basically downspeed to G3. I'll basically show you how that works. The first thing that happens is the faxes start negotiating with a CNG tone is what the originating fax sends. Then the terminating fax sends an ANSOM signal, and this is the beginning of a SG3 negotiation. When that starting fax hears this ANSOM signal, what it needs to do is it needs to send a calling menu, which is the next step of the SG3 negotiation. What we have with the spoofing feature is when that calling menu is sent, the DSPs on that originating gateway, it'll squelch or basically remove that CM message and not let it pass. So the gateway, the receiving fax machine never sees that calling menu SG3 fax negotiation message. And when it doesn't see that message, it then assumes, okay, this fax machine can't do SG3. I'll just go ahead and do a regular G3 fax negotiation and send a normal G3 DIS message. So that's how that feature works, and that's typically what is used today to handle supergroup 3 fax calls with T38. Again, this feature is enabled by default, so it's probably working a lot of times and you're not even aware of it. But that's how it's handled. But obviously the way going forward in the future is going to be having native support for SG3 over T38 in the later versions of iOS. We'll talk about SIP trunks for a moment in fax over IP. This seems to be the big trend, and I'd probably say that most of the service requests coming into TAC these days deal with SIP trunks and fax over IP. At least the service requests coming into the multi-service voice teams in TAC. And what we're looking at here with SIP trunks is there's basically 3 ways to send fax over IP over a SIP trunk. One is pass-through, which you've touched on somewhat already. But basically, you have your voice calls going out G729. When fax tones are detected, you then upspeed to G711 codec to send the fax calls through. That's pass-through. We then have what we refer to as G711 voice, and this is basically just nailed up G711 calls. All your voice calls use G711, and basically then all your fax calls use G711 as well. So it's just G711 all the time. And for some SIP trunk providers that obviously aren't supporting T38 or pass-through, this is the only solution you would have. The last solution is T38. In the future, obviously, this is going to be the best solution. But right now, there's some growing pains, so to speak. Not all SIP trunk providers support T38. Is obviously one of the biggest problems. And the other problem we've been seeing is interoperability. A lot of times, the Cisco voice gateways and the SIP trunk providers gateways are unable to successfully negotiate T38, or there's problems during the fax media transmission. So the recommendation right now is if you want to do T38 over SIP trunks, which is what you should be looking to do, we highly recommend testing that with your SIP trunk provider before rolling that into production. Next thing I want to talk about is third-party interoperability and talk specifically about a fax server, since this is a pretty hot trend right now. With a fax server, you gain a lot, and because of standards-based T38, all this is possible. If you don't use standards-based T38, there's no way to talk with other vendors' products. So in this case here, we have a third-party product, obviously a fax server, and what are the advantages of integrating that with unified communications networks using T38? Well, the first thing you're going to get is from the fax server perspective is you can now basically use Cisco Unified Communications Manager for all of your call routing. So in the case of, let's look at Cisco's own internal voice network, we have hundreds of voice gateways, and we have a fax server deployed. We actually use the Cisco fax server product, and we point it to Cisco Unified Communications Manager, all outgoing fax calls. The fax server has one dialing rule: send it to Communications Manager to get those calls out. And that works really effectively. Otherwise, we would have to have a whole other routing database and dialing rules within the fax server itself. So a centralized routing is pretty nice to have when you're deploying these fax servers. The next thing that's nice to have is the ability to communicate among various call control protocols. So a fax server is only going to talk one of 2 call control protocols, H323 or SIP. But in your network, you may have different voice gateways. You may have H323, SIP, MGCP, lots of different voice gateways. Well, without Cisco Unified Communications Manager, that fax server is only going to be to talk to one gateway type. So if your fax server is configured for H323, it's only talking to H323 voice gateways. Well, with Cisco Unified Communications Manager, your fax server can talk H323 to Cisco Unified Communications Manager, and then Cisco Unified Communications Manager can then talk SIP or H323 or even MGCP to other voice gateways. And what's really interesting about MGCP is that fax servers natively don't support MGCP, but with Cisco Unified Communications Manager, they can access MGCP voice gateways. A polling question, Daniel?
Okay, thanks, David. Yeah, let's go to our third polling question. Please mark the answer that best describes your organization's use of a fax server. Use an IP-based T38 fax server, use a fax server, but it's directly connected to the PSTN, planning on deploying a fax server in the future, or you have no plans to deploy a fax server. Go ahead, take a moment to answer. And don't forget, you can still submit a question at any time. We'll be starting the QA soon. All right, let's have a look at the results. Great, thanks guys for answering those. Let's toss it back to David.
Thank you, Daniel. So let's go ahead and wrap up some of the key points, I guess the key takeaways from this presentation today. And I'll go through these and kind of summarize what we talked about. The first thing is with Cisco gateways and T38 in general, there's two different ways that T38 works with Cisco products, with an NSE-based switchover, which is, again, proprietary, or standards-based switchover. The point here is that standards-based needs to always be your first choice. But as you'll see, what we do have is that sometimes it can't be your first choice. In the case of skinny voice gateways, you need to use an NSE-based switched over, and that's just the way things are because skinny doesn't have support for standards-based T38. But barring skinny, standards-based T38 is definitely the way to go and what you should be shooting for. The next thing with QoS, for QoS voice over IP, you can piggyback your fax over IP QoS onto your voice over IP. So, and that's the main thing to remember. And obviously, the one thing you have to remember, you have to take into account though is packet loss. That's the one area where fax over IP is a little bit different than voice over IP. With voice over IP, you can tolerate less than 1% packet loss. But with fax over IP, that can be very problematic. So you would want to use T38 and have the redundancy feature enabled if you're dealing with a packet loss scenario. Next takeaway is the support of SG3, and I've touched on this a couple of times. Starting in 15.11t, we do have support for that over T38 for SIP and H.323 call control protocols. But just be aware that if you are running MGCP or skinny voice gateways, you do not have support for that SG3 feature over T38. Next takeaway is regards to SIP trunks. I can't emphasize enough the problems we've had with SIP trunks and providers, interoperability problems, or providers not supporting T38. So just be aware that it's coming, but I would just approach doing T38 over SIP trunks with a little bit of caution. Next takeaway has to do with bandwidth. If you guys recall that bandwidth slide, T38 is very bandwidth efficient, and that's one of its main strong points. And basically, without redundancy, T38 is the same as a G729 voice call. And even when you add in multiple levels of redundancy, it's still less than a G711 call. Next takeaway, talking about Cisco products, the interoperability of running. So if you have a Cisco product running standards-based T38, you definitely have the ability to interoperate with third-party devices. In this presentation, we talked about a fax server in particular, but you also have third-party voice gateways and so forth as well that we can interoperate with. And that, again, another one of the benefits of having T38. The last takeaway is what we mentioned with the T38 slide that has to do with the header. It does not support RTP like most video and audio codecs do. So if you want to run features such as SRTP or CRTP, there's something that can't be done with T38. So that's it. I guess we'll go ahead and move into the question and answer part of the presentation.
That is correct, David. Thank you for your presentation. And I also want to thank everyone for participating in the event polling. Remember, you can still ask questions as we are continuing into the Q&A portion of the event today. Also, I want to let you guys know, please do fill out your evaluations for this webinar. The first 10 listeners to do so will receive a $20 Amazon gift card. So let's jump right into it. and head over to our first question. Is there a dream fax configuration which can be configured on H323 gateways, which works consistently with different third-party fax machines?
I don't know if there's a dream fax configuration per se. Basically, the fax configuration on H323 or any Cisco voice gateways, if you configure standards-based, you should be okay as far as interoperating with different products. This question mentions third-party fax machines, and they may be referring to third-party fax servers. And I do know that sometimes with H323, there has been some tweaks as far as negotiation within H245 tunneling and stuff like that. At least in the past, there have been. So yeah, there may be some tweaks as far as that's concerned, but it really depends on the third-party fax server, what version of the fax engine they're running, and so on. As far as having one configuration for handling all different cases and being what we term a dream fax configuration, I haven't seen one, but I would say 95, even 98% of the time, if you configure just standards-based T38 on a voice gateway, it'll work with a fax server. It's very rare that it does not.
Great, thanks, David. Let's head over to question 2. Is there any additional config required to enable T38 v3, or can I just upgrade my iOS and expect the system to use v3 automatically? And also, is v3 supported on both MGCP and SCCP?
As far as v3, when the iOS is upgraded, I'm fairly certain it still supports the version 0. If you want to do version 3, you're going to have to explicitly enable that. So that's one thing to take into account. So it's not something that's going to be automatically turned on. As far as support with MGCP and Skinny, yeah, it is definitely not supported on those. It's just supported on H323 and SIP, which obviously can be pretty big if you're using T38 on MGCP voice gateways already and you want that feature. So yeah, just H323 and SIP for that feature right now.
Great, thanks. Okay, let's go to our third question. It's looking for some clarification. Did you say that neither MGCP or SCCP supports T38 v3, or only H323 or SIP?
Yeah, just to reinforce that, it's only H323 or SIP support that T38 version 3, which gives you that SG3 support. That's correct, just H323 and SIP.
Great. Okay, let's move to our another question here. Let's assume the following topology: telco to PRI to gateway, T38 and pass-through as backup. MGCP to CUCM. COCM has a VG224 registered as SCCP pass-through and a fax server doing T38. What is the best way to set this up?
Actually,
sounds like a big question.
Yeah, it is kind of a loaded question and kind of can go different ways. So basically, you have a MGCP controlled gateway. And then you have basically a Skinny gateway doing pass-through, and you also want to do fax server T38. I've seen mixed results with this kind of a configuration. On the MGCP voice gateway, you obviously can enable standards-based T38 and what we would refer to as NSC-based pass-through or modem pass-through. So technically, a call that comes in over that PRI into the MGCP voice gateway could terminate on a Skinny port on the VG224 and negotiate pass-through is I think what the question is referring to, and then also have a fax call that comes into that MGCP voice gateway also terminate T38 on the fax server. I've seen customers have mixed results with this. Probably a better way to do this, if possible, if that VG224 has an analog fax machine connected to a specific port, change that one port instead of having it be Skinny controlled, maybe use H323 or SIP, and then you can just do standards-based T38 all the way through with the fax server. But because otherwise, what you're counting on is for a pass-through negotiation to fail with a fax server, and then for the T38 negotiation, we'll have to fail to skinny and fall back on pass-through. So it's just when you're depending on a negotiation failure for the other transport mechanism to work, sometimes that can be a little iffy. I'm not saying it won't work. I'm just saying that it can be a little more difficult, and that the best solution would be, if possible, is to change one of those skinny controlled ports to like H.223 or SIP controlled.
Okay, let's go to our next question. Are there alternative software solutions for T38 clients to the Cisco fax server?
Well, I'm not sure what they mean by T38 clients. As far as alternative solutions to the Cisco fax server, there are definitely alternative fax servers, so to speak. One of them is, that obviously Cisco has a lot of support with, is the current one that runs on the AXP that uses the Xmedia's fax solution. There's also a ton of different third-party fax servers that, as long as they support T38, standards-based T38, we'll work with them just fine. So I guess I'm not exactly sure what they mean by T38 clients, but if they want to clarify the question, I'll be happy to follow on if I didn't answer it. I didn't give the answer they were looking for. Okay,
we'll keep an eye out for that. Yeah. Let's go to another question. What about the ATA 186 and T38?
Oh, yeah, the old ATA 186. That product only supports what we refer to as NSE-based pass-through or modem pass-through. I believe new models of the ATA came out this year, which do offer T38 support. We also have smaller iOS voice gateways now, the VG202, the VG204. We also have some A81 voice gateways, and these are really small iOS gateways that do offer full standards-based T38 support. As far as that model, that new ATA 186, I'm not sure what that exact model is, but maybe it's, I think it's the 187. I think it does support T38, but the 186 does not support T38. It's only pass-through.
Okay, let's go to another question. I have a fax server and use T38 on my network, but my SIP trunk carrier does not currently support T38. What are the solutions for this sort of problem? Is it possible to transcode between T38 and G711 pass-through on Cube?
It's a good question. It's a very common question, and unfortunately the answer is no. There's no way to transcode on Cube between T38 and pass-through. And this is one of the, I kind of alluded to this with a SIP trunking slot I had. With SIP trunks right now, it's very tough. Either there's no T38 support by the provider, or like I said, we've been seeing interoperability issues. So in this scenario here, there are some workarounds where people have basically taken a voice gateway and basically sent the call out via just like a T1 loopback cable, have it come back in. But I've seen mixed results with stuff like that, and you're basically doing a transcoding it using that kind of a solution. Again, mixed results of that solution. For some people, it's worked fine. Other people have not had much luck with it because it does introduce more delay. And unfortunately, there's not a solution, a good solution, ideal solution right now for that, because there is no transcoding on Cube, and I hate to say it, but it's almost you're going to need to wait for to have that T38 support by the SIP trunk provider.
Okay, great question. Let's move to another one here. I am a little confused by NSEs. Why were these implemented by Cisco for T38 when standards-based T38 was available?
This is going to be a confusing answer as well. So basically, you ran into a situation where there were Cisco environments where you had Cisco Unified Communications Manager, and support was not available yet in Cisco Unified Communications Manager for negotiating that T38. So they went ahead to go ahead and get T38 on the voice gateways in these environments with Cisco Unified Communications Manager. They basically came up with this NSE method to bypass Cisco Unified Communications Manager. Plus, it gave T38 ability to skinny voice gateways, which the skinny protocol does not have the ability to negotiate T38 within the protocol itself. So it seems, I guess, well, okay, basically a Band-Aid for some limitations in call manager at the time and for the skinny protocol. So it allowed networks that had Cisco gear to run to use NSEs and get T38 without having to go to a standards-based solution. Obviously today, with the proliferation of fax servers and obviously third-party gateways and so forth, standards-based is where you want to be. But if for whatever reason it doesn't work, you have skinny voice gateways or whatever, the NSE-based solution is there as a backup.
Okay, great. There's another question. I'm having problems getting my IP fax server to talk to a Cisco ISR. There seems to be some sort of issue with the initial H323 negotiation. Any ideas on troubleshooting this?
Yeah, obviously on the Cisco voice gateway, you probably need to go ahead and look at the H323 negotiation. Probably the H245 debugs, but that can be not a lot of fun to look at. Probably the best way to troubleshoot this would be to get a Wireshark trace. They have a VoIP call analysis feature within Wireshark, and it'll actually break down graphically for you the negotiation for H245, and typically you'd be able to find the problem there. As I mentioned previously, there have been some problems before with H245 tunneling, and some fax servers did or did not support that, and there were some issues on that with Call Manager. The other thing to look at is some of the fax servers have a stage setting that can be adjusted. Without seeing the actual debugs, it'd be hard to kind of pinpoint it, but I guess the answer would be I'd start with a Wireshark trace, and if that doesn't narrow it down, then obviously Cisco Support or using the forums on Cisco Support community would be the next step.
Okay, there's another question. What are the weaknesses of T38 protocol?
I'd say the weaknesses, at least from the Cisco perspective, there's probably two. The lack of RTP header makes the T38 protocol not support features such as secure RTP. And I was working with a large financial customer who wanted to have their fax transactions secured. And this was a deal killer for them with T38, unfortunately. And so they ended up having to go with a pass-through solution. It takes up more bandwidth, but they were able to use secure RTP, which is what that was a more important demand for them than having the T38. So obviously that would be a weakness, the lack of RTP support. The other weakness I've run into, not as much anymore, as a lot of this legacy gear is no longer being used, but older Cisco gear, such as 6608, somebody mentioned the ATA 186, devices like that, the VG248, they don't support T38 at all, or they don't support standards-based T38. So I'd say legacy product support could be another weakness of T38.
Okay, I think we have time for just one more question. I'm considering removing my fax server T1 connection and using T38. Any gotchas to look out for while making this migration?
The main thing is going to be obviously when you pull out that T1 connection, you have to make sure you get those DIDs obviously routed into a voice gateway. You then are going to have to make sure you understand what call control protocol you're going to be using to connect to that fax server. Obviously, if you have Cisco Unified Communications Manager involved, you can use MGCP gateway, H223 or SIP. If you're just going to move that that T1 connection, all the DIDs over to just a direct connection model with just a gateway directly to a fax server, then you're going to have to use H223 or SIP. So obviously, figuring out which call control protocol you're going to be using to talk to the fax server would be the main thing to look out for. Also, if you're going to be moving this over to a SIP trunk, make sure your provider supports T38, and obviously do a little bit of testing to avoid any kind of interoperability issues.
Great, thanks, David. So we've run out of time for questions, but if you have additional questions, you can log on to the Cisco support community at the URL posted here. David will continue answering your questions at this community site over the next 2 weeks. If you have not had a chance to explore the Cisco support community, please take a moment to check out this excellent resource. That's https://supportforums.cisco.com. Also, make sure you check out our next Ask the Expert event coming up here on December 14th, where our topic will be the Cisco AnyConnect client and configuration and troubleshooting. We're also welcoming a new series, the Cisco Live and Networkers Virtual Environment. The well-known TechWise TV crew will be hosting new episodes, and we have another one coming up here on December 1st at 10 a.m. Pacific time. Be sure to come back and check it out. It's a great series. We also encourage you to explore the virtual environment, including the Cisco and partner booths in the world of solutions, the on-demand technical sessions in the session catalog, and the blog center. That's all located right here in Cisco Live and Networkers Virtual. We have a couple of different guest options if you'd like to upgrade your guest membership. You can go up to the Virtual Premier Pass, which will give you full access to the entire environment for only $395 US or 5 Cisco Learning credits. If you're only looking for a few specific sessions, we also have an option for you as well. Our new a la carte pass enables you to purchase individual sessions for only $45 US each. Be sure to check it out. I'm going to thank you again for your time and your questions today. Please do take a moment to fill out the evaluation, and we'll see you at our next Ask the Expert event. Thanks again to David for being our expert today.
Thanks, Daniel.